So section 4.4, we're going to take a look at radical functions. We're going to split it into part 1 and part 2. Part 1 is the longer part, part 2 is shorter. So basically anything that has some type of root in it, like a square root, cube root, those are what we call radical functions. And a lot of what we do, we're going to break down the root as to whether it's what we call an odd root, like a cube root, or an even root, like a square root. I'm going to break those down. Those are different examples. Any questions on why these would be considered radical?
Why?
Because they have a root in them. So I'm going to kind of break down some of the pieces of this and just go through a few terms. So first of all, this thing that I just circled here, that is called a radical expression, just the part that I circled. When you write a radical expression, this number that you put here has to be a number that's 1 or higher, higher than 1, and it has to be an integer. So here's an example of another radical expression. That's the 4th root of 12. This is the 5th root of 3x. Those are both examples of radical expressions. They're not equations because they don't have equal signs in them. Now it's an equation you can solve. Okay? So radical expression, what I just circled, radical equation is that whole thing I just circled. So this number here, I'm going to tell you in a minute, is called the index, and that has to be higher than 1, and it can't be a decimal. It has to be an integer.
Okay, so to recap, the 12 right there has to, like, the number inside the root has to be bigger than 1, or what number?
Yeah, that number right there.
Oh, that number, okay.
The n. Listen. And again, that number n is called the index, which I think I write down in a second. So, okay, so that whole thing is called a radical. This thing, it's a radical, or you can call it a radical expression. It's the same thing. The number that you put on the outside of the root, that's kind of a small number right there, that's called the index of the root. It tells you the kind of root that you're doing. If you just write that and you don't put an index, we always assume it's a square root. If you want that to represent something other than a square root, you need to put a number right there that tells you what the root is. So n is the index. The part that you put underneath the radical sign, that's called the radicand. So in this one that I just circled in red, 12 would be called the radicand. It's what's underneath the root symbol.
How do you spell that?
R-A-D-I-C-A-N-D, radicand. Right, if I did something like square root of 4x, 4x would be called the radicand. It's just,
What if there's more than one number underneath?
it's the whole thing.
Okay. So the radicand would be 4x plus 2?
In that one, 4x plus
Okay.
3. Yep. Now, if you had 4x plus 3 and you put a times 5 in the front, the times 5 is not part of the radicand.
Yep.
That's not under the root. So A, what I'm calling A, right there, A is the radicand because it is underneath the root. And then the actual symbol itself, you can call that a few different things. You can call it the radical sign, radical symbol. You can see either one of those names. So any question on what I mean by radical sign, radicand, index, or radical expression? I already said that to you. If you do not write an index, you just put something like this. We assume that it is a square root. Square root has an index of 2. Okay, so how do you type in a root on a calculator? Well, let me show you. Square root, there is a button for it. To type in a square root, you press second, and then you press the x squared button. So if I type in like square root of 16, what's the calculator going to tell me? 4. Yep. Now, if you want to do something other than a square root, let me show you how you do it. Let's say you want to do cube root. To do a cube root, first thing you do is you press 3. That's going to be the index. After you put in the index, you press math. And then you're going to go down to option 5. So math, and then when you press option 5, it turns that 3 that I typed in, turns it into the index. And now you can type in any number you want. So when I hit enter here, what would the cube root of 8 be? 2. Yeah, cube root of 8 is 2. If you want to do a fourth root, type in 4, press math, and go down to the 5th option. Now you can do a fourth root. That's how you do it. Now, let's say that you wanted to type in cube root, but you didn't have a calculator that could put a 3 as the index. Okay? There's another way that you can type roots in rather than using like the buttons that I did there. You can use fractional exponents. For example, if you want to take the square root of something, and let's say you didn't have a square root button, but you did have a button that can raise things to powers. If I type in the square root of 25, square root of 25, I get 5. If I type in 5 to the 1/2 power, I also get 5. So raising something to the 1/2 power is exactly the same as taking the square root. It's the same thing. So here's the square root of 49. What power could I raise 49 to? And it would be the same as taking the square root. 1/2. Yep. So just type in, you could either type in 1 divided by 2, or you could put in 0.5. I get the same answer. How about if I wanted to do the cube root of something? What power do you think that would be the same as?
0.75.
1/3. Yeah, it's going to be a fraction. And it would be 1/3. So if you wanted to do the cube root of 8, let me type that in again. And you did not have a button for doing cube roots. Instead, you could take 8 and raise it to the 1/3 power. 1/3 and cube root are the same thing. All right. How about let's look at this one. How about a 5th root? That would be the same as to the 1/5. And what happens with this one is when you change the 5th root to 1/5, you have x to the 4th to the 1/5. You have a power raised to another power. What do you do with these two numbers when you have a power to a power?
Don't you add them?
You add them when you have something like this. So if you had like x to the 4th times x to the 5th, you would add them. But this is a little different. This is x to the 4th to the 1/5. It's a power raised to a power. Anyone else remember what you do with these two numbers?
Multiply?
You multiply them, yes. So that's one reason why you might change something from a root to an exponent, because it allows you to simplify it.
Why don't you multiply the denominator just because you don't?
Because when you multiply 4 times 1/5, when you multiply fractions, you go straight across. 4 times 1
Oh, yeah.
and 1 times 5. Yep. So you get 4 over 5. All right. Any question on that one? Right? How about if I had, let's say, the sixth root of x squared? What is the sixth root the same as? 1/6. X squared to the 1/6 power. And because that's a power to a power, what would you do with the 2 and the 1/6?
Multiply and then simplify.
Yep. And what do you get if you multiply 2 times 1/6?
2/6,
2/6,
which is 1.
which is 1/3. Yep. And what's that the same as doing? Raising to the 1/3 power is what root?
Is cube root.
Cube root. So taking the sixth root of something squared really just means to take the cube root. It's a simpler way of saying what we started with. At least I think a cube root is simpler than a sixth root of something squared. So any questions on simplifying that? Okay. So let's take a look at a few things with even and odd roots. Okay, so how do you solve for what's called a principal root? First of all, when you see the word principal root, it means you are solving for one answer. In general, when you do a root, you could get as many answers as the index, which means if you're doing a square root, you get 2. If you're doing a cube root, you could get 3. Fourth root, you get 4. Fifth root, you get 5, and so on. But if they specifically say to solve a problem, and they write down the word principal root, that means they want one answer. Okay, so how could you get more than one? Well, if you take the square root of 25, the calculator tells me it's 5. So 5 times 5 is 25. What else times itself gives you 25 besides 5 times 5?
25 and 1.
-1.
So it has to be a number times itself. Yep. -5 times -5 is also 25. So the square root of 25 has 2 answers, 5, -5. But if they ask for the principal one, we are solving for one answer. Okay?
So would it be either of those then? You just pick one?
No, so I'm going to write it down right now. So for even roots, we want the positive answer. So if I say find the principal square root of 36, you would say 6. Is -6 also an answer? Yes, but it's not what we call the principal root. For odd roots, well, could be positive or negative. Could be positive or negative. Let me show you why. So let's take the cube root. So math, option 5, cube root of 8. And what did we get earlier when we did that? Two. Now let me take the math option 5 cube root of -8. What times itself 3 times is going to give you -8? -2. So in that case, the answer comes out negative. So when we're dealing with an odd root, we could get a positive or a negative answer. When we're dealing with an even root, we only want a positive answer. The other thing is, notice the radicand here. It's a positive number. The radicand here is a negative number. When you're dealing with odd roots, the radicand can be any real number. Any real number. Let's try that with an even root. Let's see what happens if we try to take the square root, and we do a negative number. Square root of negative 25. Anybody know what's going to happen if I try to take the square root of a negative number?
It's gonna come out to a positive.
No, it's gonna be negative.
So what times what would give you negative 25? But it has to be the same number.
Negative 5.
Negative 5 times negative 5? That would give you positive
Wait, no.
25.
There can't be.
Yeah, there can't be a real number. When you try to take the square root of a negative number, it doesn't say it can't do it. It just says the answer is not real. So what does that mean it would be? It would, yeah, it would be I, it would be an imaginary. So we're not dealing with imaginaries. So when we do even roots, square root, fourth root, sixth root, the radicand has to be 0 or higher. It can't be a negative. Zero is okay. I don't know why some people think you can't use 0. You can use 0, that's fine. You can't divide by 0. But you can take the square root of 0. You get 0. So
Wait, that's only for even roots?
yeah, it's only for even roots. Odd roots, it's not a problem for the radicand to be negative, and that's what I showed you with the cube root of negative 8. It worked fine. So for odd roots, you can take the root of any number. Even roots, it has to be 0 or higher. Yeah.
Could you keep that up just a second?
Yep. So again, what it means to solve for a principal root, and then a few different facts about even and odd roots. And then the answer could be positive or negative. Here, we want the positive, just the positive answer.
Alright, okay.
All right, so what I want to look at now is what happens when you take a square root of a number. Does it get larger? Or does it get smaller? What happens? All right, so let's try that first one. If x is 4, what do you get when you take the square root of that?
2.
You get 2. Okay, so in that case, it gets smaller. All right, let's try this one. Okay, square root of 18.
4.24.
Yeah, I think that's what it does come out to, 4.24. What happened that time? Smaller or larger?
Got larger.
Small. What, the number,
Like,
18
it
got
got
smaller?
larger than 2 or larger?
It got, well, compared to what you started with.
Oh, okay, yeah, it got smaller.
It got smaller. How about 1? 1. So what happened that time?
Same.
Stayed the same.
So that time we take the square root, it stayed the same. So we can't say when you take a square root, it always gets smaller. Sometimes it doesn't. It stays the same. How about the square root of 0.5?
Hager.
Yeah, 0.7.
0.71, right? So when you take the square root of 0.5, you get a bigger answer. So the question whether when you take a square root, does it get smaller or larger? Depends. Depends on what you take the square root of. That's just what I want you to understand.
How is the square root of 0.5, 0.7?
Because if you type in the square root of 0.5,
But
You get
how is
0.7.
0.7 times 0.7, 0.5?
well, 0.7, let's do 0.71 times 0.71. 0.50. Because when you're taking a square root of a number smaller than 1, it has to get bigger. Let's try out square root of 0.2. Second, square root of 0.2 comes out to 0.45. So you're kind of thinking like to take the square root of 0.2, you have to multiply two numbers together that are going to give you 0.2.
So every number 1 and under is going to be larger?
Yeah, it gets larger. Yep.
Okay, and
Because if you took a number that was smaller than 0.2 and multiplied it by a number smaller than 0.2, you'd never get 0.2. The only way you can multiply two decimals together and get 0.2 is if the two decimals you multiplied were larger than 0.2. They just have to be.
It's strange.
Yeah, just kind of a weird thing that happens with square roots. Now, let's graph a few different square roots and compare them. Okay, I'm going to graph some even roots. A square root, a fourth root, and a sixth root. So let's do square root. For square root, you have a button. You can just press second and then press x squared. How am I going to type in the fourth root?
Math, or the 4.
4, yeah.
Math. 5.
And then 5. Okay, so there's my fourth root. And my sixth root, I'll do there. So I just want to graph all three of them and see how they look. Okay, see if we notice anything they have in common, anything that looks different. Let's do zoom 6. Zoom 6 is a good starting window, but we might have to zoom in a little more to kind of see what's going on.
What'd you just graph?
Those three functions on the right side.
In separate.
Yep, y1, 2, and 3. Okay. Let's start to look at it a little bit. Anything that you notice about these in terms of the direction that they go in? Yes, they all go up and
They're all coming to the right.
to the right. They all go up and to the right. None of them are going in this area. So let's just zoom in then so we can see that better. So let's zoom in from 0 to 10. And for the y, let's go like 0 to 5.
Where's the math?
Math, it's right below the alpha button, third one down on the left-hand side.
Yeah.
So let's go set our window 0 to 10. There's no reason to look at negatives because they don't go that way. And let's go 0 to 5. Okay, so I'm going to set my window just like that. And it's going to zoom in on this box, and I want you to kind of see what's happening right where I circled. Okay, so there's the square root. Square root is in blue. The fourth root is in red. And now you're going to see the sixth root in black. Okay. Anything that you notice about all of those roots? That's not the picture that I had. It's not copying it over. All right, we'll just look at the calculator then. Anything you notice about all of them? Yep.
It's like the first one starts the lowest, then goes to the highest.
Yeah, they kind of all switch places
Yeah.
at one point. Like when you get to the right, like far to the right, the blue one is on top, then the red, then the black. That's the order. Blue, red, black.
Yeah, it looks like at like 0, 1 they'll change.
Yeah, at 0, 1, the order switches. So instead of blue, red, black, it goes black, red, blue. Switches the order. Yep. And 0, 1 is a point that is common to all of them. Yep. Let's write that down. So not 0, 1, 1, 1 is a point that is common to all of them. And there is another point that's common to all of them, but it's hard to see. They all start at the origin.
So what? 0,
0, 0.
0, 0.
Yep, they all start at 0, 0. And they also all go through the point 1, 1. How about the domain? Look at any one of those graphs. What's the lowest that those graphs went to?
I mean, they start at 0, 0, so that's the lowest.
So 0 is the lowest. And how far to the right do they go?
Infinite.
Infinite. So that's the domain.
0, infinity.
0 to infinity. Yep. And it does reach 0. Now, how about the range? How low do the graphs go?
It's like 0 probably.
They go as low as what number?
0.
Yep, they go as low as 0. And how high are they going to go if I kept zooming up?
Probably.
Infinity, yeah. looks like they start to flatten out, but they never do. Okay, if you zoom in or you zoom out more, you'll see that they all just keep going up. It's slow for like the 4th root and the 6th root, but it still keeps going up. So the range is all numbers from 0 to infinity. 0 to infinity. Okay. So there's a few different things with even roots. What's the other kind of root we could look at? What is it? Yeah, let's look at an odd one.
Wait, can you go back just 1 second? What was the 0, 0, and 1, 1, comma to all?
Yeah.
What I missed there?
Those are two coordinates that they all pass through.
Oh.
They all pass through the origin, and they all pass through the point 1, 1. Yep. Okay, let's do a 3rd root and a 5th root. Okay, so I'm just going to graph 2 of them. So if you already have it typed in, you can just highlight the index and change it. You don't have to go through and type it in from scratch. Okay, so these are odd roots. Okay, I'm going to start with zoom 6, and hopefully you'll notice a big difference right away. What do you notice right away about an odd root?
It doesn't start at the origin?
No, it doesn't start there. It does go through it, though.
Yeah.
Yep.
It goes through like negative 2.
Yeah, it goes negative. And that's because when you're dealing with an odd root, the radicand can be any real number. It doesn't just have to be greater than or equal to 0. Yep. So it goes left and it goes right. Let's see if I can get a picture of that. Yep. Okay, so it goes to the left and it goes to the right. I don't think you can really see, but there is a point there that's common to all of them. Yeah, the origin is 1. Let's set our y min to be like -2 and y max to be 2. So it's going to zoom in. The only problem is going to be it gets very steep in the middle. When things start to get really steep, the calculator gets confused, and it almost looks like there's a gap. That red line should be connected. But what I'm trying to do is zoom in so you can see another point. It doesn't seem to like me doing that. Another point that they all have in common.
0, 0.
0, 0.
It's like almost 0, 1? Yeah, it's probably 0, 1.
So 0, 1 would be right up here.
Would it be 1, 1?
1, 1. That's another point. Again, if I can make it a little bigger.
Oh, yeah, 1, 1, I meant. That's what I meant.
Let's see if I switch my window. No, even when I change it, it's still grabbing the old screen.
If you do zoom and then zoom in and you click on the spot, that's what I did.
Oh, he wants to get the pictures on the other side, so we can see it.
I'm just going to change the window. Let's see. No, it's still grabbing the old one, even though the new one's different. So I don't know why it's doing that. But yeah, they do go through the point 1, 1, and there's another point where they cross too. -1, -1. So those 3 points are common to all the graphs. -1, -1. That's right here. 0, 0, and 1, 1. Okay. Let's look at the domain. How far left and right does this graph go?
Infinity.
Yeah. So the domain is all real numbers, and the range is also all real numbers. It's going to keep going up forever, and it's going to just keep going down.
So wait, so domain is left and right and range is up and down?
Yes. Yep.
I forget that stuff.
And for odd roots, they go left and right forever, and they go up and down forever. Even roots, well, that's what we just did on the other page. Even roots are different. They only go in one direction. Okay. Any question on that? Okay, so graphically, even in odd roots, they look they look very different. So what I want to look at now is a transformation. Okay. So we've talked about like shifting up and down, shifting left and right. I think we just did that with rational functions. Now we're going to do it with radicals. Okay, I'm going to copy that over bigger so we have it.
Is that an equation for transformations?
Yep, we're going to label, and we've done it before, what the A, the B, and the C do. These transformations are very similar. In fact, they're not even similar, they're identical to what we've done before.
Is the plus or minus D outside of the?
Yes. Okay, so let's start with inside. Okay, inside stuff is always horizontal. Okay, when you are inside the radical, the A and the B are both going to do horizontal stuff. What does adding do? Is adding a stretch or a shift? Yeah. No, multiplying is a stretch. So adding is going to be a shift. And since the A is inside, it's horizontal. So A is a horizontal shift. Which way would plus move out?
Right, or up? Wait, horizontal. Yeah, right. It'll go right.
Okay, so that's one option, right? Or it also could move left. When we did it for rational functions,
Wait, why would plus go left? I thought you said left is negative and right is positive.
well, what did we say when we did rational functions?
I do not remember.
Anyone remember that? When we had, did we have a chart we did for that?
Yeah.
We did the chart, okay. So so the A and the B are on the inside. So this stuff is always horizontal. Adding and subtracting is a shift. Multiplying, which is what we're doing with b times x, is not a shift. What do you get when you multiply?
Stretch.
You get a stretch.
Yay.
Let's talk a little bit more about each one. So for the shift, when you add a number, adding is going to move it to the left. Okay, I can show you. Take and graph, just graph the square root, and then graph the square root of x plus 2. When you do x plus 2, that is going to move it to the, it's not doing square root. It's going to move it to the left. You might think plus, it should go to the right, but watch what happens. There's the original. Now watch the plus 2. It moved it to the left. So plus moves it to the left. Which way would minus move?
The right.
To the right. So it's backwards. B. Okay, B is a horizontal stretch. As an example, let's say you have this. Square root of 3x. B is 3. That is going to be a horizontal stretch by factor of 1/3. A and B are backwards. So you think plus would move it right? It doesn't. Plus moved it left. You think putting a 3 here would stretch it 3 times as big. It doesn't. It actually makes it 3 times as small. What if I had square root of half x?
Would it be 2x?
So you might think, oh, it's a small number, it's gonna stretch it smaller. Nope, small numbers stretch it bigger. A and B are always backwards. So this would be a horizontal stretch.
Wait, so first you have letters, now you're making it all backwards?
These are just examples of different B values.
Yes.
B could be 3, or B could be a half. I'm just showing you how you would write it.
Can you go over the top of that for 1 second? Top of that, yeah.
How about C? What kind of transformation do you think C is? First of all, it's outside the red box.
Vertical.
Would be a
So it's
vertical
definitely a vertical something, and it's multiplication.
stretch.
Vertical.
Right. Multiplication is always a stretch. Outside the red box is always vertical, so it's a vertical stretch. That one, what's that?
So confusing.
The vertical one isn't backwards. Okay, the stuff outside the red box, what you see is what you do.
Oh, that's amazing.
So let's say you had 3 square root of x. That is a vertical stretch by a factor of 3. Vertical is always normal. So 3 square root of x, vertical stretch by a factor of 3. 1/2 square root of x, vertical stretch by a half. How about d?
Vertical shift.
That's outside the red box, which means it's going to be vertical. And because it's adding or subtracting, it's a shift.
Is it still the same positive left and negative right?
Nope. Vertical. What are your 2 directions you can go for
Up
vertical?
and down.
Up and down. And the vertical is not backwards. So what direction do you think
Up,
plus would be?
up.
Plus is up
Thank you.
and minus
Down.
down. If you ever forget, you can always just graph one and look at it. Do square root of x, and then do square root of x, and then do plus 3. It should move it up 3. But if you forget, just try it and watch what happens. So plus 3 moved it up 3. So that's a chart that describes what the A, the B, and the C do. Let me write down a couple things I said. A and B are backwards.
So why does it like,
C and D are, I don't know what you call it, they're not backwards, they're,
Normal.
we'll call them normal. Positive is up, negative is down, it's what you would expect.
so the square root is what makes it like backwards?
Yeah, so square, well, what makes it backwards is it's just that it's A or B. It's the part in the right box. Any type of horizontal transformation is always backwards. And it was also backwards when we studied it here. This -4 is not going to move it left 4. That's going to move it, it's going to move it right 4. Yep. Because minus always goes to the right. And now I was just starting to write it here. And I'm going to do the same thing on ours. If the b is a negative, what does a negative b cause to happen?
Shift to the right.
No, what did we write down, right? Or about to write
Use the
down?
multiplication, right?
B is multiplication, and if it's a negative, it causes your graph to,
Stretch. Right.
no. If b is negative, you get a horizontal reflection.
Oh, that's,
Okay. So it's the same as this chart. There's no difference. If b is negative, it causes your graph to reflect horizontally.
if he's negative, I'm gonna have to be in yours.
Sounds good. I'll be right there.
So if b is negative, get a horizontal reflection. What do you think would happen if c is negative?
Oh, the world's gonna end.
Doesn't it reflect too?
It does cause a reflection again.
Over the x, no, vertical?
Yeah, it's a vertical reflection.
Good morning, Cupcake.
So I know it seems like a lot, but it's the same. We did them here, and we did them in another section before it, and we did them another time before that. The A, the B, and the C, and the D, they never change. And we're going to study them again in the next section when we do exponential functions.
When do we do trig?
Okay? But
After Christmas.
the A, the B, the C, and the D all stay the same.
What did you say happens if B is negative?
If B is negative, it's a horizontal reflection. So there are 6 transformations that can happen. Horizontal shift, horizontal stretch, horizontal reflection. vertical shift, vertical stretch, vertical reflection. Those are always the 6. But they never change, no matter what type of function you're studying. Rational, radical, logarithm, exponential, trig functions, the A, the B, the C, and the D do exactly the same thing every single time. They never change.
Wait, can you said vertical shift and then what?
Wait, is there a difference between the capital B and the lowercase b?
What do
No,
you think?
Well then,
I can just use lowercase.
uh,
So let's try
well, thank you.
an example.
Hey.
So look at
What?
g of x equals the square root of x minus 2. What I want to write down is what transformations you'd have to do to the square root of x to turn it into the square root of x minus 2.
Wait, so I have a question. Would the 2 in there be an A?
Well, let's scroll up and
Yeah.
look at the
Yes,
chart.
that would be an A.
So what position is the 2 in?
Huzzah!
Eh.
It's in the spot that's an A. What does A do?
I don't know.
Horizontal shift left.
Oh, look at the board and you'll know.
What's the X then?
X is the X.
2. So it doesn't do anything?
No, we're not looking at, you're not looking at that. You're looking at the A, the B, the C, and the D.
Oh, 2.
Mr. Hager, this is my favorite class.
It will move to the right.
Yeah, so it's gonna move it to the right,
Right, 2.
and it's gonna move it 2. So the first step is, look at the
What are
number,
you, second point?
look at the number, look at what letter it represents. That says it's a horizontal shift, and it's a negative, so that means it's a horizontal shift to the right. So you just write down, step 1 is shift right 2 units. And that is the only step, because there is no B, C, or D in that problem. Let's try this
A lot of
one.
those in the test.
What spot is the 3 in? The A, the B, the C, or the D?
A.
It's in the
It's gonna
A,
go to the
Straight
left
left.
3 degrees.
and that's going to be a positive, so it's going to move it to the left. So when you write it down, make sure you write shift left 3. And you can say units, it doesn't really matter. Shift left 3 is what's happening. All right, let's try this one. First of all, what do you notice about the radicand here?
It's before. And
Well, it's 3 minus x, but what's wrong with it?
The X is in first.
The x isn't first.
So you
This is the order it's supposed to be in. So we need to fix it so it's in that
move
order.
it.
Oh.
So I go plus
It's the
3.
same thing.
No, it's negative.
Okay, I give up.
So how would you fix that so it's in the right order?
Can
I'll go
you,
home.
can you add the X to the front?
You just flip it.
Yeah, you just flip it. What would it be if you flip it?
X minus 3.
Well, X plus 3.
Wait.
We don't have an x there though.
What do you mean?
Negative X.
Plus 3.
Plus 3.
Three.
Now it's in the right order where you can have the x first and then the number second. So you want to make sure it's in the right
Just
order.
shift left.
So it is.
Okay.
Shift left 3.
So yeah, there's 2 things happening.
Okay.
First thing is the plus 3. And what did you think that does?
Left, left.
That does shift left 3. Shift left 3.
Is it possible to have to make you sit?
Shh. And what about this negative in front of the x?
It reflects over
So
the horizontal
it's B.
axis.
That's in the spot where b is, and it's negative. So what does it say if b is negative happens?
Over the horizontal.
Yeah, it's a horizontal reflection.
Wait, so would that just be like a horizontal reflection, like 1?
So a horizontal reflection means if it originally looked like this, now it looks like that.
But like if it's just negative x without the number there, is it just 1?
Yeah, just like a negative 1. That means there's no horizontal stretch. It's just 1. It stays the same. How about, let's do another one. 2 times the square root of x plus 3. Okay, how many transformations are happening here?
3.
3. No, 2.
Just 2. Yeah. There's only two numbers.
Shut up.
Guys.
It's not nice, man.
What's the first thing that's happening?
There's a horizontal shift of 3.
Yep, so you have to look at them
Right 3.
in that order.
Left.
Start with A.
Left.
It's a plus, it's going to the left. So shift, left, 3. Now, is there anything in the B spot?
No, but there's
No.
something in the C.
Other than a 1 there, there's nothing. So we can skip B.
Let me have a vertical stretch.
Go to the C, yep. So how would we write that one?
Vertical stretch of 2. No, yes.
Yeah, vertical stretch by factor of 2. Yep. So vertical stretch by factor of 2. How about D? Is there anything in the D spot?
No.
No. You can think of it as plus or minus. There's nothing there, so it's just a 0.
Hager.
Touch my butt.
Does it matter what order you do it in?
Yep. A, then B, then C, then D.
Oh, okay.
Yep.
Oh, sweet. Okay.
How about
There's
2 times the square root of x minus 5 plus 6?
okay.
How many transformations there?
3.
There are 3. Okay. Start with A. Is there a number in the A spot?
Yeah.
What's the number?
Horizontal shift to the right. of
It's a minus 5, so it's a shift right 5. Okay. Is there a number in the B spot?
No.
No, just a 1, so we skip that one. Is there a number in the C spot?
Yes.
Okay. What number?
Vertical stretch by stretch.
So yeah, it's a 2, and we say vertical stretch. S-T-R-E-T-C-H-I, triple spelling stretch. Vertical stretch by factor of 2. That's the C. And is there anything in the D spot?
Yes.
This time there is.
A vertical
Vertical
shift
shift.
up
Up.
6.
Yeah. So it's a positive and it's up. So shift up 6. So that's how you
I
describe
think you dropped something.
transformations.
Wait, why? Oh, factor of 2. I thought it's factor of 6. Shift up.
So this chart, again, it's the same chart we're going to have for every function we study all year. A is always horizontal shift, B, and etc. They all stay the same every time.
Great.
Any other questions on the chart or using it to describe stuff? Okay.
What?
So now we're going to look at drawing a square root, okay, by hand. I think that'll be the last thing. So when we are sketching radical functions, okay, there are really 2 main types. There's the odd ones and the even ones. When you're dealing with an even one, okay, think of a square root. What direction does that normally go in? Like if you were to graph a square root. To the right. Right? Square root function, unless you reflect it, it looks like this. It starts here and it goes to the right. So square roots have a start point. How about when we did the cube root? What direction did that one go in?
Right.
Well, what did we say the domain was for odd roots?
Hey boss, are you still recording this?
Yeah.
Wasn't it all real numbers?
Yeah, the domain was all real numbers. So odd roots start at a center point and they go in both directions. So the difference between an odd root and an even root, an odd root has a center and goes in both directions. An even root has a start and it only goes in one direction. So regardless of what type of root we're sketching, we always want to find that new start or center, if it's an odd root. So, to find that new coordinate, the new start or center point is going to have 2 numbers in it. It's going to have an x value, and it's going to have a y value. To find the x value of where your new graph has moved to. You're going to set the radicand equal to 0 and solve. What's the radicand again?
Answer.
Yeah.
Isn't that like the little number in the square root thing?
So the little number, that's the index.
Gotcha.
So,
It's the stuff inside.
It's the stuff inside the square root. It's just the stuff underneath it. So you're going to set what's underneath the square root equal to 0 and solve it. And that's going to give you the new x value. Okay. Once we have the new x value, we can plug it back into our formula, and that gives us the y value. Because you're going to have a formula like this. Once you set this equal to 0 and solve it, you're going to get an answer for x. Let's say x comes out to 2. If x comes out to 2, you can plug it back in, do 3 times 2, take the square root of 3 times 2, and that'll give you the y value. So you find the x first, and then you plug it back in, and that's the y value. What kind of root looks like this again? An even root or an odd root?
Even.
Even. What kind of root looks like that?
Odd.
Odd. When you are finding an odd root, it's a little bit more work because you got to graph this way and you got to graph that way. When you're doing an even root, it's less work because you only have to graph in one direction.
But like when it's an odd number or when an odd root, it's just like the same numbers but negative, right?
Yeah, it's like it's kind of symmetrical. Yeah.
Okay.
Okay, so once you figure out that point, if it's an even root, check a couple more points in that direction like that. And then draw your picture. If it's an odd root, check a couple points in that direction and a couple points in that direction. I'd say usually I do 3 on each side, and that'll give me a good picture. So if it's an odd root, I'm probably going to have to do 6, 3 and 3. If it's an even root, just 3. All right, so let's look at a couple. Let's just start by looking at this one. Is this graph going to go in one direction or both? Both. Why?
the 3.
Because it's the 3. The index is an odd. So we're going to have to check a couple points on each side of the center. Okay. First thing we have to do, though, is find the new center. How do I find the x value?
Equal to 0.
Set what equal to 0?
The equation.
Not the whole equation,
The inside.
just the inside part. That's all we have to set equal to 0. 3 minus 2x equals 0. And what would be my first step to solve that?
Minus or plus is minus 3.
Yeah, you could minus 3, or if you add the 2x, then it makes everything positive. Then we don't have to deal with any negatives. So you could add the 2x, or you could minus the 3. And then what would be your last step? 5 by 2. So that is the new x value for my center. And again, how do I know this has a center and not a start?
Because it's odd.
Because it's an odd root, yes. Yep. So
Wait,
my,
so if it wasn't even root, would you do the same thing?
I would have still done the same thing, I just wouldn't have called it center, I would have called it start.
Okay.
But I still would have done the same math. Yep. Okay, so I got 3 halves for my x. Now, what do I do with that to find my y?
So
Plug it back in.
Plug it back in. Okay, so let's fill that back in. What's 2 times 3 over 2?
I don't know.
No idea.
2 times 3 over 2, yeah. The 2's just cancel out. That always happens when you do this. And you get just 3. So that becomes 3. What's 3 minus 3?
0.
0, right? That should come back out to 0. If it doesn't, then you didn't find the right number here because you set this equal to 0. So by plugging it back in, you're basically checking it. You get 3 minus 3 is 0. What's the cube root of 0? 0, because 0 times itself 3 times is 0. And what's 0 times 2?
0.
Still 0. And then plus 1. So that is basically your y value. It ends up always being the number that's added or subtracted. So that's going to be the center of my graph. Okay, 1.5 comma 1. So let me get graph paper and graph that point. Now, because it's an odd root, should we check points on one side or both? Both. Yeah. And the quickest way to check them, if you don't want to plug them in by hand, okay, type that in on the calculator. 2 times 3. So 2 times the cube root, 3 minus 2x, plus 1. And we're going to use the table. If you want to check the point you already found, you can. Try 1.5, and you get 1.5 comma 1. That's exactly what we got. So we know the center is correct. What would be a couple more points to the right of 1.5?
Would you want to check like 2.5?
Yeah, I would say kind of space them out in that whole area. We could do 2.5 or 3. So 3, we're at negative 1.8. 1, 2. So maybe about right there. What would be another good one? 5. So we could check that one. So 5, we're at negative 2.8. 1, 2, about right there. And what would be one more good one?
7.
Sure, 7. So 7, negative 3.5. 7, 1, 2, 3.5. Okay, so that's good for the right. What would be a couple points we could do to the left of that one?
-1.
Okay, we could do negative 1. And we get 4.4. I usually do 0 just because I like to know where it crosses the axis. So I probably wouldn't have done negative 1, but it's okay. 0, a little less than 4. Okay, and let's do one more that's spaced further over.
7.
Negative 7. So negative 7, just above 6. 4, 5, 6, 7, 1, 2, 3, 4. Okay, so that's enough points. You should be able to get an okay sketch. Something kind of like that. So we got a center point, goes in each direction. Okay, that's the harder one because you got to check both sides. Any question on that one? So the only thing you have to really do by hand is just find this point. The rest of it, we use the calculator. All right, let's try this one. 3 times the 4th root of 4 minus 3x minus 2. We're not listing them, but how many transformations are in that one?
4.
4. 1, 2, 3, 4. Horizontal shift, stretch, actually, and a reflection, so there's 5. Shift, stretch, reflect, stretch, shift. Okay, so there's a lot of transformations.
Wait, why is the symbol like its own thing?
Why is the symbol its own thing?
He's
So 5.
I'm not sure.
You said the 4, they're the negative, or like the minus sign.
This negative, yeah, that's a reflection, because if you rewrite the inside properly, the b value is 3, and it's a negative. That does 2 separate things.
Okay.
When the b is negative, it causes a reflection, and it has a 3 there, so that's a horizontal stretch by 1/3. Okay. Remember, it's backwards. All right, so now, are we going to have a start point, or are we going to have a center point? Yes. This is going to have a start point, which means it's only going to curve in one direction. Which way do even roots normally curve?
Right?
Normally they curve that way. Curve to the right. That negative is going to cause the graph to do what? Reflect which way? Horizontal. A horizontal reflection means it's going to curve that way. So this graph is going to curve to the left. there's some other things that are going to happen too. It's going to shift and stretch. But the biggest thing that's going to impact it is this negative. It's going to cause it to go in a totally different direction. So just something to think about when we plug in points. If we plug them in on the wrong side, we're going to get an error.
So what order would you do that? Like if you were doing it by hand, would you do the 3 times x first, or would you do the...
You do the A, then the B, then the C, then the D. So you always follow the order. A, B, C, D.
Yeah.
If we were going to list them, but we're not listing them. So let's find the start. How do you find the x value for your start point?
You have to take the negative 3x plus 4.
Yep, take the radicand and set it equal to 0. It doesn't matter which one you use. I just wrote it this way on the bottom because someone asked about transformations. Other than that, I wouldn't worry about doing that. Okay. What would be our first step to solve that?
You have to add 4. No, subtract 4.
You could subtract 4, then you're going to have to deal with negatives, which is fine. You could do that. Or what if I just want to avoid negatives?
Plus 3.
Yeah, just add the 3x to the other side. Now I don't have any more negatives.
Now divide.
Yep. And then divide by
3.
3. So what is the x value of my start point?
4.
4 thirds. And how do I find the y value?
You have to put it back in.
Plug that back in, right there. What's 3 times 4 over 3?
4.
Those just cancel out. So you get 4. 4 minus 4?
0.
0. And the 4 through the 0?
0.
And 0 times 3?
0.
0 minus 2.
Minus 2.
Minus 2. That is my start point. So it's 4 thirds, which is about 1.3, negative 2. Oh, right there. And which way did we say this is going to curve? It's going to go to the left. Let's put it in. And let's try doing a point that goes to the right. Okay, let's say we didn't know that it goes to the left. Okay, so it's a little tricky. You got to be careful when you type that in. You got to do 3, then press times, then 4. Then you can do the 5th option down, and that's your 4th root. It takes a little practice to get that typed in right. Let's check 4 thirds. When I put in 4 thirds, what should I get for y?
Negative 10.
And I do. So we confirmed that we found that right. And now let's pick a point that goes to the right, even though we know this graph doesn't curve to the right. What's an x value bigger than 4 thirds?
5.
2.
So what's happening?
This is an error.
There, it doesn't go, the graph doesn't go that way. So you're trying to draw the graph in the direction it doesn't go. So we got to pick numbers that are smaller because it goes to the left. I would say pick like 3 points. What's a number that's smaller than 4 thirds?
1/3.
Yeah, we could do 1. That wouldn't work. Let's do a couple others.
1/3. 0.
Yeah, we could do 1/3 and 0. They're kind of close. Let's space them out a little more. Negative 5, and then maybe like negative 10. Okay, I probably would have just done negative 5, negative 10, and 0. Those would be spaced out. Okay, so let's put that right here and draw those points. Don't worry about the ones that said error. That was the wrong way. We can ignore those. So we got 1, 1. We've got 0, 2.2. We've got negative 5, 4.2. 5, 1, 2, 3, 4.2, about right there, and negative 10, 5.2. All right, so we're going to get a graph that kind of does something like that. Okay, it starts here. It doesn't go any lower than that. That's it. That's the start point. But it does keep going that way forever. So which direction does it keep heading in forever? left and
Up.
up. Yeah, up. It doesn't head up quick, but it is going to keep heading up very slowly. Yep. And that's how you sketch an even root. All right. So any questions on sketching the even root or the odd root? Okay. Let's copy this one down. I just want to see if you can tell me the transformations. What was on the end? -2. Okay. How many transformations did we say are happening here? 5. 1, 2, 3, 4, 5. Almost every transformation that you could have. There's 6 total. This one doesn't have the vertical reflection. You need a negative in the front. What's the first number that we look at?
-4.
The -3, that's the B.
+4.
The +4 is the A.
It's a horizontal shift
Left.
left.
Yep. So that's a shift left 4. Is there a number in the B spot?
Yes.
Negative.
Well, we're going to look at the negative separate because that causes something else.
Horizontal shift stretch.
So we're going to put horizontal stretch. And remember, it's backwards.
Would it be like 1/3?
Yep. Horizontal stretch by factor of 1/3. So that takes care of this and that. What does the negative in front of the B do?
It means it's a horizontal
Horizontal.
reflection.
Horizontal reflection. So you did your horizontal, horizontal, horizontal. All the horizontals done. That's that came from the A. And the B does 2 things. What's the next letter we look at?
C.
C. Is there a number in the C spot?
Vertical stretch.
Yep. Vertical stretch.
Factor of 3.
Yep. Factor of 3. And is there a number in the D spot?
Yeah.
Yep.
Vertical shift
Down 2.
Shift down 2. Yep. Very good. That's a complicated one. You always do your stretching first, and then your horizontal first, and then your vertical stuff comes last. Just follow the chart. They're usually not that complicated, which is why I wasn't even going to do that, but I thought you guys could handle it. All right. Any other questions on that?
I got one. So when it reflects, does it have to be a negative sign in either spot that it multiplies or divides?
To do a reflection, you either need a negative here, or you need a negative in front.
Okay.
Those are the only 2 places that a negative would cause a reflection. There or there. If this one had a negative here, then right here, you would have said vertical reflection as step 5. And then step 6 would have been shift down 2.
Okay, and is the reflection always over just the origin of the line?
It's either over the x-axis or the y-axis.
Okay.
Yeah. So, just in case people aren't clear, this is a horizontal reflection. Horizontal means you flip left to right. This is a vertical reflection. It means you flip up to down. So horizontal, vertical. All right. So that is the homework for tonight. So tomorrow we got plenty of time to review that. It's 1 through 3, 5 through 8, 11 to 14, and 18. And then we'll finish up 4.4 tomorrow.
What unit is this? 4.
This is 4.4. And I'd say we did like 75% of it today.